Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve a numerical problem which is based on the eccentrically loaded welded joints. So this is a case where this is a welding where load is applied vertically down, and you can see there are two fillet welds, one this side and another that's other opposite side. A welded joint is shown is subjected to eccentric load of 2 kilonewton. So P is equal to 2 kilonewton, which is equal to 2000 Newton. Find the size of weld if the maximum shear stress in the weld is 25. Tau max is 25 Newton per mm square, as 1 megapascal is equal to 1 Newton per mm square. Now this S is, we have to find S. Okay. Now E is given as 120, eccentricity is given as 120 mm, and length of the weld is, you can see L is equal to 40 mm, which is given in this. So this is rectangular, suppose. So this is 40 mm, so 40 mm this side and 40 mm other side is the length of weld. Okay. Now what will the area of the weld? Area of the weld is equal to throat thickness into length of weld, okay, into 2, because welding is both side. Okay, so it will be 2 into T into L. Now this is size of the weld S, and this is T, throat thickness. So from this relation, if this is 45 degree, then sin 45 is equal to T by S. From here P is equal to S into 0.707. okay, so you can keep it here, 2 into 0.707 into S into L. This is the area of weld. So if you keep the values, 2 into 0.707 into L is 40 into S. So if you multiply it, then you will get 2 into 0.707 into 40, 56.56 into S mm square. So this is area of the weld. So what will be the direct shear stress? Tau is equal to P upon A. Okay, so it will be equal to P is 2000 Newton divided by area is 56.56 into S, okay, which is equal to 35.4 divided by S, Newton per mm square. So this is tau we have calculated. Now bending moment, what will be the bending moment up to here? So it is force into eccentricity, so it is 2000 into 120, which is equal to, this is M, this is equal to 240 into 10 to the power 3 Newton mm. Now we have a formula that for beam, M upon I is equal to sigma upon Y. Okay, so from here sigma is equal to M Y upon I. So here M is, we have calculated 240 into 10 to the power 3. Now I is equal to BH cube by 12. Similarly Y is H by 2. So Z will be equal to polar modulus, section modulus is equal to I upon Y, which is equal to BH square by 6. Okay, so if you put this value here, so M upon Z, sigma will be equal to M upon Z. Okay, so Z will be equal to BH square by 6. Okay, so in this case width will be equal to throat, because at that point the joint will be weakest. So T into H is length of the weld, L square by 6. Now T is equal to 0.707 into L square by 6. So it will be equal to 0.707 into L is 40 square by 6. So if you will calculate it, and this is S, so this is S, so this is 188.53 S, okay, mm cube. Now this is only for one side, okay, one side weld we have considered only L is equal to 40. So there are two sides of the weld, one this side and other opposite side. So it will become Z is equal to 2 into 188.53 S. So it will become 377 S mm cube, okay. So now sigma will be equal to m by z. So it will be equal to, m is already known to us, 240 into 10 to the power 3 divided by 377 S, okay. So it will be equal to 636.6 divided by S Newton per mm square, okay. Now what will be the maximum shear stress? If you have read normal stresses, then you will know the formula of shear stress, maximum shear stress. So from there you will get maximum shear stress is equal to half under root sigma b square plus 4 into tau square. So it will be equal to half into 636.6 divided by S square plus 4 into 35.4 divided by S square. So it will be equal to 320.3 S. Now tau maximum is also given to us in the question, which is 25 Newton per mm square. So this will be equal to 25, okay. So from here S will be equal to 320.3 divided by 25. So it will be equal to 12.8 mm. So this will be the size of weld. So I hope you understood this problem. If you have any doubt, then you can ask in the comment section, and if you like this video, then please share and subscribe. Thank you for watching.